Assalamualaikum and welcome to everyone. So today we are from Group 7 are going to present about database management system. So this is our group members. We have Siti Nasharina, Muhammad Hadif, Siti Noarisha and Yasmin Batrisha. This will be what will be covered in our video. We have introduction, objective, and content, analysis, case study, key findings, results, and conclusion.
Assalamualaikum and hi everyone. My name is Siti Nusharina binti Mahyudin and I will be presenting on the topic of Database Management System or DBMS. Let's begin with a brief introduction. A database management system is a very important in computer system engineering. It helps make sure that the data we manage is accurate, reliable and efficient, especially when we are dealing with large-scale dataset. In today's digital world, especially with the technologies like cloud computing, big data, and enterprise system, DBMS plays a critical role in storing and retrieving data. The relational database in particular help us recognize and relate data properly. This improves system performance and scalability, which is crucial in the building reliable computer and efficient computer system. The main objective of this presentation is to explore how relational database SQL and data normalization or denormalization can improve the reliability and performance of computer system. I also touch on how this concept help manage complexity in system engineering. Now let's talk about relational database, which are often described as a backbone of DBMS. So, what exactly is relational database? Basically, it stores data in form of tables. These tables are also called relation. Each table is made up of row which represent record and column which represent attribute. There are two important concepts you need to understand when working with relational database: the primary key and the foreign key. A primary key is a unique identifier for each record in a table. For example, in a student table, we might use student underscore ID as primary key because each student has unique ID. A foreign key, on the other hand, is used to link one table to another. It refers to a primary key from a different table. For instance, if we have a table of student and a table of department, the department underscore ID in the student table could be the foreign key that links to the department table. These keys are essential for maintaining relationship between the different data set and ensuring data integrity. Let's look at an example to make the difference between primary and foreign key clearer. Here, we have two tables. One is the student table and the other is department table. In the student table, the column ID is the primary key. It uniquely identifies each student like AB, SC, AD, and so on. Now, take a look at the column called D in the depth in the student table. It contains value like AI underscore DEPT, DMS, DEPT stands for department, and so on. These are linked to the ID column in the department table, which is the primary key of that table. In this case, the department in the student table is acting as a foreign key because it refers to the ID in the department table. This relationship helps us connect students to their respective department and keeps our database well organized and consistent.
Okay, hi, my name is Yasmin Batrisha binti Adeli. My matrix number is B08221039. So I will talk about data normalization. What is data normalization? That means a systematic process of organization data in a relational database to minimize redundancy and improve data integrity. So, primary goals that have three, which are reduce data redundancy, improve data integrity, and avoid data anomalies. What is reduce data redundancy? Storing the same pieces of data only once. So, improve data integrity is ensuring data is accurate, consistent, and reliable. What is avoid data anomalies? Avoid data anomalies have three, which are insertion anomalies, update anomalies, and deletion anomalies. Insertion is difficulty adding data. Update anomalies is inconsistent data after updates, and deletion is unintentional data loss. And next, I will talk about process of normalization, normal form. which is NF. So normalization is achieved by applying a series rules called normal form. So key normal form has 4 or 5, which are 1NF, 2NF, 3NF, and B, C, and F. And higher NF is 4 and 5 as is for more complex scenario. So I will explain about 1NF, which is first normal form. This atomic value in each cell, no repeating groups, each row is unique, which is identified by a primary key. Okay, next I'll talk about 2NF, second normal form. 2NF must be in 1NF, and all 9 key attributes are fully dependent on the entire primary key, which is no partition dependency. Next is 3NF, which is third normal form, and 3NF must be in 2NF. Non-transitive dependency, like 9 key attribute, do not depend on other 9 key attribute. So last is BCNF. What is BCNF? Boy's Code normal form, which is stricter version of 3NF, and higher NF, which are 4, 5, and as if for more complex scenario. Okay, next I will talk about the benefit and when to use the normalization. So first I will talk about the benefit of normalization. First is minimize the redundancy, like save storage and space. Second is enhance the data integrity and consistency. Third is easy data modification, like update, insert, delete are more straightforward. Next is flexible database design, like easy to extend and modify. Last but not least is clear the data relationship. So that's all the benefit. Then we move to the when to use the normalization. We use the normalization when primarily for OLTP. What is OLTP? Is online transaction processing system. Like example, banking system, order entry, and student registration. When the data integrity, consistency, and efficient write operation like insert, update, deletes are critical. Then when avoiding the data anomalies is a high priority, and as the foundational data design for relational database for considering the denormalization. So that's all for normalization.
So next is data denormalization. The definition is the process of intentionally introducing control redundancy into a normalized database schema. So the primary goal is improve read performance, query speed, by reducing the need for complex and numerous joint operations. It's essentially the reverse of normalization, often applied strategically after initial normalization. The common technique is adding redundant columns, copying frequently needed attributes from one table to another, creating pre-join tables or summary tables, storing results of common joins or aggregations, using derived attributes, storing calculated value instead of computing them on the fly, combining tables, merging tables that are very frequently joined. So next is benefits and drawbacks of the normalization. The benefits is faster query execution. For reads, fewer joins lead to quicker data retrieval. Simpler query writing, queries can be less complex. Good for read-heavy applications. Drawbacks is increased data redundancy, consumes more storage space. Potential for data inconsistencies. If redundant data is not updated consistently across all locations, risk of more update anomalies. More complex update process requires careful management to keep all copies synchronized. Can make the schema less clean if overdone. And then when to use denormalization. Primary for OLAP, online analytical processing systems and reporting. Example, data warehouse, business intelligence dashboard, and analytical queries. When fast retrieval of large amounts of data for analysis is critical. For rate-heavy applications where query performance is a bottleneck. When preparing flat data sets for machine learning model training, often a single table with all features is preferred. Important, usually considered as after a normalized design as a performance optimization strategy.
We proceed to the case study of this topic. So this case study highlights how relational database and SQL are used in e-commerce platforms like Amazon's. These platforms manage large volumes of data, customers, products, orders, and SQL helps retrieve the data quickly and efficiently. For example, we can use a simple query to find all orders from one customer, like this. So, relational database ensure structured storage, reduce duplication, and maintain data integrity, making them ideal for managing complex relationships in online businesses. We proceed to another case study that highlight the importance of data normalization and denormalizations. So, in this table, it basically shows how data normalization and denormalization are used in real-time system. So, normalization is about organizing data to reduce repetitions. For example, platforms like Amazon store customer data once and link it to many orders. This keeps the data clean and consistent. To normalize, we split the big tables into smaller ones. Banks do this also to keep customer and transaction data organized and easy to manage. On the other hand, denormalization focuses on speed. Big data store often combine sales and customer data into one table to make report faster, even if it means repeating some data. In places like telecom, denormalized data helps speed up analytics, even though it uses more storage. In short, normalization helps keep data clean, while denormalization makes system faster. The best choice depends on what the system needs, accuracy or performance. Okay, for the next one, this case study explain how relational database handle heavy loads, especially in banking systems. Banks deal with thousands of transactions every second, so the database must be fast and reliable. To help with this, we've used things like indexing and query optimizations. For example, adding an index to customers like in this SQL command, create index IDS customer name on customer names, makes data searches much faster. This optimization helps the system respond quickly, even when many users access it at the same time. That's why relational databases are perfect for high traffic systems like online banking. For the key findings, we focus on comparing the query performance between normalized and denormalized database. Starting with normalized database, these structures are great for reducing data redundancy. However, they often require multiple table joins to retrieve data, which increase query time, especially for complex operations. On the other hand, denormalized databases are designed to reduce the number of joins, which makes them faster for complex queries. But the trade-off here is the redundancy and a higher risk of data inconsistency. If we look at the table comparison, we see this clearly. For simple join queries, the normalized version took 0.96 seconds, while the normalized one took only zero point 0.5 seconds. When we move to complex join query, the difference becomes even more obvious. Normalized took 2.83 seconds compared to just 2.35 seconds for the denormalized setup. This performance difference is modeled in the formula shown, which factors in both the number of joins and rows and the time cost associated with each. So the key takeaway is normalization support clean and consistent data but may slow down complex query. Denormalization, on the other hand, speeds them up but at the cost of storage and consistency. The best approach really depends on whether the system prioritizes performance or data integrity. So we proceed to the results. So as you can see, we're comparing query times between normalized and denormalized database for both simple and complex join queries earlier. So the key insight here is that the normalized database consistency perform faster. This is mainly because they require fewer joins, which reduce the total processing times. For the simple join query, the difference is minor. Normalized took slightly longer, but when it comes to complex joins, the gap becomes more noticeable. The normalized setup had a total time around of 56 units, while the denormalized one complete in just 50. So even though normalization ensures cleaner data structure, the denormalized format clearly offers better performance, especially when handling more demanding queries. This reinforces the idea that choosing between normalized and denormalized structure really depends on the system priorities, whether we value data consistency more or query speed under load. The conclusion to this topic is that the database management system are important tools that help store, organize, and manage data efficiently. They make it easier to access and update information while keeping it secure and accurate. Today, many organizations use DBMS to support daily operations and decision making. With the growth of cloud computing and big data, DBMS continues to improve and adapt to new technologies. In short, DBMS is a key part of any system that relies on data.